All right, so the first lesson we're going to go over is it a function or not when it's graphed, or is it linear or not when it's graphed? So each question, when I'm going to show you here, is going to ask you, is it a function or is it linear? So a function means that for every x, there's exactly one y, which means if you choose any x here, okay, if I choose this x, there should be only one answer, okay? So if there's one, I should make another one here. If there is at all, ever, a part of the line that's on top of it, then it's going to be not a function, okay? So if any part of this is ever directly above it, then it's a no. All right, so this one, no matter where I look on the x, there's always only one answer, okay? So this is totally a function. Now, linear or nonlinear means straight line or not a straight line. So is this linear? No. Is this one linear? Yes. Is it a function? Yes. Again, anywhere you choose, okay, it only has one answer. If I choose this one answer. If I choose this one answer. This one answer. Okay, so it only has one answer. So we're good. What about this one? Is this linear? I don't know. It does make a straight line, but it has a bend in it, which means no, it is not linear. This is not linear. Okay, is it a function? Yes, it is a function. Okay? This one, is this a function? No. Okay, I can easily find a couple spots where there's two answers for one x. Okay? There's two answers for one x. If that happens once, it's not allowed. You see how the purple line is on top of itself? That's not allowed. This one, is it linear, this one? No. Is this one linear? No. But now we're just checking if it's a function, okay? It's not a function because of this one and because of this one. They're right on top of each other. That's not allowed. You're not allowed to have any part of the graphing on top of itself. Here, is this linear? No. Is it a function? Yes. Okay, pretty self-explanatory on those. Those are pretty easy. Okay, so for this one, okay, we need to pull out the slope and the y-intercept. Okay, for this one, they call it slope or rate of change. Okay, so rate of change and the slope are the exact same thing. So slope is what we're going to find here. Okay, we need to find the constant rate of change. So it's going to be 1, 1, 1, 1. So x is going up by 1. Okay, and the y is going up by 3. Okay, remember that y goes on the top, rise. Y controls rise. So rise over run. 3 over 1. Oh, well, that's 3. So slope is 3. Now, how do I find the y-intercept? Okay, the y-intercept is when x is 0. Okay, so if we know the path, we can actually backtrack. Okay, when x is 0, that's my y-intercept. So if we're going up by 1, I'll go down by 1. If we're going up by 3, I'll go down by 3, and I'll find out that the y-intercept is 1. So the y-intercept for this one is 1. So if I have the slope and I have the y-intercept, I can write it in slope-intercept form, which is y equals the slope, x, and then the y-intercept, which is a positive 1. There's my equation for this line. Okay, what about this? Here I don't have to write the equation, I just have to pull the slope out and I have to pull the y-intercept out. So the y-intercept is here, so the y-intercept is -4. What is the slope? The slope is 2 over 3. Remember, if you ever see this missing, if there's nothing there, the slope is 1. Okay? If there's nothing here, the y-intercept is 0. All right, what about here? Let's pull the y-intercept out of here and the slope out of here. So the y-intercept is 10. It says it right there. Y-intercept is 10. Okay? Remember, they also call that the initial value. All right, now this one, what's the slope? Well, it's going up 20, and it's going to the right 1, 2, 3. and it's going to the right 3. So 20 over 3 is the slope. So the slope is 20 over 3. If I wanted to write the equation, I don't know why I wrote slope. If I wanted to write the equation, it would be y equals the slope 20 over 3, x, and then plus 10. All right, pretty simple. All right, let's go over here. Now we're gonna see if it's linear or not. Now, on a graph, I already went over that, so we're gonna go over chart and equation. So in a chart, to check if it is linear or not, you have to check its increase. So goes up, up, up. This is going up by 1, by 1, by 1. So this is consistent. Okay, so this one also has to be consistent. This is going up by 1, then going up by 3, then going up by 5. That's not consistent. Because when I make the slope 1 over 1, it should be the same as this one. 3 over 1, that's not the same. 5 over 1, that's not the same. So the slope is not consistent. It's not going up at an exact rate, which means this is not linear. Okay, if it were linear, it would make the same fraction every time, even if it jumped around. Like it would be 1 over 1, 1 over 1, 1 over 1, or 2 over 1, 2 over 1, 2 over 1, or it could be like 2 over 1, and then 4 over 2, and then 4 over 2 again, but 4 over 2 and 2 over 1 make the same fraction. So they are consistent, they just skipped a couple numbers, but they skipped it at the exact same rate. Okay, so not linear, non-linear is actually more appropriate, non-linear. Now this one, this is linear. Why? Because I'm allowed to add, subtract, multiply, and divide to the x. I'm not allowed to do anything extreme like an exponent or put the x in the denominator of the fraction. I'm not allowed to do that. I'm not allowed to use square roots. I'm not allowed to use absolute value. These will create things that are non-linear. If I'm just doing the basic multiplying and adding, okay, then it is linear. Okay, I'm allowed to do any of these things. When y is by itself and it says something like this is linear. If I do something odd like this, that's non-linear. Okay, if I erase this, it's still linear. Why? Because I'm doing the same thing every single time to the x. Every single time I put a number in here, I'm multiplying by 7. Every single time I put a number in this equation, I'm multiplying by 7 and adding 3. Every single time, the same thing is happening to the x. If I do this, then it is not the same thing. Why? Because if x equals 3, okay, I'm going to do the exponent first, which means 3 times itself. So I'm multiplying by 3, and then multiplying by 7, and then adding 3. If I put a 4 in there, now it's going to be 4 times itself. So now I'm multiplying by 4, then multiplying by 7, then adding 3. The number changed. The sequence changed, which makes it non-linear. Okay, the same thing has to happen every single time to the variable for you to say it's linear, because it has to be consistent all the way through. Okay, so here's the last thing. What if I gave you 2 points and asked you to write the whole equation? Find the y-intercept and everything. Okay, well, if I get 2 points, you can easily find the slope, right? So this is x1, y1, x2, y2. Okay, so this goes first, right? 7, 2, minus, minus. Then 5, 1. That's going to be 1 over 2. So my slope is 1 over 2. Okay? So we know that the slope is now 1 over 2. But I have to finish the equation. I also need the y-intercept. Okay? So now, what can I do? Well, I can fill in these 2 spots with any of these, whichever you deem to be easier to deal with. For me, it would be probably the 5, 1. Why not? Or actually, no, the 5, 1. So let's use the 5, 1. So y equals, so I'm replacing y with 1. I'm replacing 5, I'm replacing x with 5. Right? And now I don't know what b is. Well, I'm going to multiply these. 1 equals 2.5, right? 2.5 plus b. Then I'm going to, well, if you're wondering how I did that, I multiplied by 5, and then 5 times 1 is 5, divided by 2 is 2.5. So now I just have to get rid of 2.5. Minus 2.5, minus 2.5, I'm left with negative 1.5 equals b. So now I know what b is. B is negative 1.5. So now I replace b in the formula with negative 1.5, and I have my equation. So you solve for the slope, and then you plug them in to find b. Here, okay, slightly easier, they gave you the y-intercept. So you know that this is 2.5. Okay, so you know that that one is 2.5. Check. Now I have to find the slope. How do I find the slope? Now you could plug it back in or use the point they gave you. If you remember, the y-intercept is when x is 0. So this, even though it doesn't look like it, is a point. They gave you a point. 0, 2.5 is what they gave you. So you can use that point to find the slope. So we'll use the 0, 2.5, we'll use the 4.5 and negative 4.25 minus minus, and then I'll write 0 and 2.5. So now this is going to be negative 6.75 over 4.5. Okay? Which will give me negative, I'm going to shift over twice to make them both whole numbers, 675 and 450. Both of these are divisible by 25. So we're going to divide them both by 25. So 25 times 4, because there's 6 100s, that's going to make 24. So 27, so it's going to be 27 on top, over, it's going to be 4 times 4 is 16, plus 2 is 18. Okay, both of these are divisible by 9, which will leave me with 3 over 2 as my slope. So now that I know what the slope is, it's going to leave me with 3 over 2. Here's my equation, okay, for this one. And that's it. It's all the work.